Hey guys, it's Mrs. Riley, and this is your Chapter 1 test review for Algebra 2. And I'm just going to go through it. Remember, pause whenever you need to pause. That way you can take notes and really learn something and do really well on the Chapter 1 test. Okay, so number 1 here it says, what's the parent function for y equals absolute value of blah, 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 blah? Okay, it doesn't matter what's there because the parent function is an absolute value function. The basic, just straight up, there it is, the absolute value function. Because it's an absolute value problem, the parent is an absolute value function. So that's that. We are done already with that. Now, number 2 says sketch the graph of the function by making a table of values. We could always just put this in our graphing calculator. You bet we could. But there's a couple things I want you to notice here. It's always happening. That looks like 4, negative 4. That looks like negative 3. This one also looks like negative 3, and this one looks like 4. But where this vertex is happening is when x is 0. So if I plug a 0 in for x, right there, 0 squared is 0, minus 3 is minus 3. Okay, so I know it is not negative 4, and it is not positive 4. It has to be negative 3. So I've narrowed my choices now to C and to B, and I need to pick another test point to just see where on the graph it goes. So let's say that I'm going to let x be 4. Okay, I'm going to let x be 4. So if I plug a 4 in here, 4 squared is 16. So I have 16 minus 3, which is 13. So 4 should give me 13. 4 should give me 13. 4 should give me 13. That was an easy pick. It was choice B. Now, if you put this into your calculator, so see, I'm going to go a lot of back and forth today, and we'll see how that works. So far, not so good. Okay, here's my calculator right here. I put it in x squared minus 3, and I graphed it. I can definitely see that it's going through negative 3, and I can see that on the x-axis it's really close to 2. But let's go back to where we were. That doesn't really help us over here because these also look pretty close to 2. And so I think we really needed to do a test point. I meant to say 13 here, didn't I? We really need to do a test point to see, hey, wait a minute, it's got to be way up high. It must be answer choice B. Okay, now remember, if I'm going too slow for you, you can always fast forward too. So pause, work out the problems, fast forward, whatever you guys need to do so that you're learning. The goal is learning. All right, it says graph the function, describe the transformation. It's 2x squared. Okay, well 2 is on the outside, so it's a vertical something. So let's look at our words. Vertical, 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 vertical. Okay, that doesn't help us. Then this one says shrink, shrink, stretch, stretch. Well, we know that since it's on the outside and it's a 2, it is not a shrink, not a shrink. It is a stretch. Okay, so now what we have to decide is it going to be narrower? So look how the blue here is on the inside of the parent function, that black one. Or is it going to be wider? See how the blue here is on the outside. And it is in fact going to be narrower because 2 is greater than 1. Now, if you graph this in the calculator, that's fine. Hopefully you would be able to see that it's definitely this narrower one and not the wider one. Okay, basically same problem again. It's 3x squared. It is a vertical, shrink, or a stretch. Let's see. This is vertical, 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 vertical. Okay, so that doesn't help us. But 3 is bigger than 1, And so we know it is a stretch. So we're looking at this answer and this answer. So these guys are gone. And again, 3 is bigger than 1, so it's going to be narrower, so the answer choice must be C. If in doubt, graph it out, but there it is. Okay, number 5 here. It is 4 times the absolute value of x. Why do we have so many vertical stretches? Wow. It's a vertical stretch. Again, you shouldn't even need me on this one. It's the third one in a row we've done. It's going to be narrower. Okay, over here, here's some good stuff. Let's go with our transformations. This minus 2 for sure means I'm going down 2. So that black function you see here on all these pictures, that's the original, that's the parent, that's the x squared. And so we know for sure we need to go down 2. So this one went up, so it's wrong. And that one appears to have gone down, and that one went down, and that one went down. Okay, so far that helps us there. Then I'll change colors. This plus 3 on the inside, what's it mean when it's on the inside? You do the opposite. Actually means that we are going to the left 3, so it couldn't be this graph. Okay, so far it's A and it's D. And then this minus 2 means it opens down. This is the only one that opens down. So A is the winner. Now, here's the deal, guys. And this was the deal back in chapter 1 anyway. If you want to, you plug this into your calculator. So I'm plugging it in right now as we speak, as you could be too. Minus 2. I'm going to switch the screen and show you. There it is. Here it is. I could have picked the correct answer without doing any work. That is the glory of calculators right there. Okay, let's move on. Alright, it says write a function g whose graph represents the indicated transformation. They want us to translate this 3 units to the left. 3 units to the left. Okay, it is actually pretty small for me here, so I'm going to change it. Aha, fantastic. Left would be on the inside. So basically we're going to take the inside and move it left, which means we are adding 3 to the inside, because it would look like this. F of x plus 3 on the inside. So if that's the only change, then this 2 still needs to be positive. Okay, these guys are wrong. And we know that left is on the inside, so the 7 is not going to change to be a 5. So we didn't even do the work yet, and we know it's A. But let's go ahead and do the work. So it's 2, and then everywhere where you see an x, you don't write the x. Instead, you write what's supposed to go on the inside instead, which is x plus 3. So it's 2. And then x plus 3 minus 8 is x minus 5. And the minus 7 didn't change. See that? We found the right answer. Okay, over here, they want us to write the function again, I believe. Yep, write a function whose graph represents the indicated transformation. Okay, so f of x is right here, they're telling us. The f of x is x plus 3. See how it's x plus 3, but it's going through minus 3? See how they're the opposite? So what we know is, since we are going through plus 4, our f of x is going to have a minus 4. So look for a minus 4. Here's a minus 4. Here is a minus 4. So these guys are wrong. Okay, now Did the function turn and go upside down? Because this one is saying, hey, you open down now. No, it did not, which means this is our answer choice here. Okay, this is going to be a reflection in the x-axis. Do you remember what a reflection in the x-axis is? It is when the negative is out front. So you take the entire function, you buckle it up when you put a minus out front. So that's going to change this sign here and change that sign there. So is it a positive 8 anymore? No, it is not. And it needs to have a negative right like that. So it's answer D there. Okay, number 10 says we need a vertical shrink by a factor of 1/5. If you remember, vertical is what it is, so it is not that. Vertical is what it is. And the other thing you need to remember is vertical is on the outside. And what I mean by that is it's 1/5. Ooh, I got squigglies there. And it's your f of x. So you're going to write your entire function down, so absolute value of x plus 10, and then you're going to buckle it up in those parentheses and plunk a 1/5 out front. Then you have to distribute that 1/5. So is that 10 going to stay a 10? Oh no, it's not. It's going to turn into a 2, and we get that answer there. Okay, over here we're doing a vertical shrink by a factor of 1/2, followed by a translation 2 units down. So remember what vertical is. Vertical is what it is. You put the 1/2 out front of the function. So it cannot be these. Those ones are both wrong. So after we do our shrink of 1/2, then, see it says followed by a translation of 2 units down. So we're going to get this one because the function was x. So first we get 1/2 of x, and then we need to move it down, so we subtract the 2. Okay, over here we're just finding the function again. Let's see. The black here is the absolute value of x. This blue one is the translation or the transformation. And the vertex I can see is at -3, -2. So here's the -2 because that's down 2. So those are wrong. And then, ooh, check that out. They're both +3, so that makes it easy on us. This one opens down. This one opens up. Ours opens up. So it's this answer choice. Okay, use the linear regression feature on a graphing calculator to find the line of best fit for the data in the table. All right, this is it, guys. Do you remember how to use the linear regression feature? If you don't, you need to find your cheat sheet, or you need to grab a post-it note or something right now and write down these instructions, because I am going to reteach you how. Okay, so we're going to grab our calculator. Let me grab it here. Ta-da! Calculator. And the first button we need to press is this button right here for stat. And we want to edit it, so either press 1 or press enter. And go into your L1 and your L2 and get all of your data in there. So see how I put all my data in there already. And as soon as you're done with that, you can press second quit. So second quit. Now we're on our main screen. We want stat again. This time we don't want edit, we want to calculate the linear regression. So go over, and then we choose quadratic. No, we're choosing linear regression. So press 4. And it says, did you use L1 and L2? Yeah, we did. Store reg EQ, we don't even need to do that because we only need the equation. So we go down to calculate, we press enter. We get this gorgeous equation right here. It's telling us that the A value is 2.60357, blah, 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 and the B value is 68.60. So go back to your test now, or your review, and which answer goes along with that? Well, hey, fancy that. Only this answer has that. But we can check the centimeters just to be sure. So go back to your calculator and do 2.60 times. We're talking about a femur who's 38 centimeters long. I'm doing it right now. Plus 68.60. Aha, hey, I got that same answer. So for sure it's this choice here, C. So one more time, what we do for our linear regression is we press stat and we edit, then we quit. We go back to stat and we calculate linear regression. We're done. Perfect. Ooh, solve the system. Okay, we learned matrices and we also learned by hand. But this one, just looking at it, looks like it's going to be special because this is a 2 and a 2 and a negative 12, and this is a negative 1 and a negative 1 and a positive 6. So I'm going to multiply the bottom here by 2. So hold on, this is 2x plus 2y equals negative 12. That's just that first one. Then this one multiplied by 2 is negative 2x minus 2y equals 12. And when I draw my line, I get 0 equals 0, which is true. So true ones have infinitely many solutions, and we are done already. Aha, now this is a triple, and it looks like it's going to have an answer. So let's get ready to put it in the calculator. And the reason I say it looks like it's going to have an answer is because A says no solution, but then B, C, and D, they all have numbers for us. So I'm pretty sure we're going to have a solution here. So grab your calculator and get ready for matrices. Okay, so in matrix A, what we're going to do is a negative 1, a negative 5, a negative 5. Matrix A will also have 4, negative 5, 4, and 1, 5, negative 1. Do you remember this? This is our matrix equation with the x, y, z. And then now we need our constant matrix for C. So, ooh, I have scribblies. We have 2 and 19 and negative 20. Okay, I'm trying to find the calculator here. And the camera appears to be frozen. Yay for technical difficulties. For sure. Come on, camera, it's hard to edit these videos. Okay, well, we're going to just give up on that for now. Let's set up 16, and then we'll see if the camera's going to work for us. So over here on 16, oh, now look at this. Look at this. This is a 6, and this is a 6, and this is a 2, and this is a 2, but this is a 2, and this is a 6. And also, look at your answer choices. You have no solution, and you have infinitely many. I bet you that there's not a solution this time. So let's go ahead and just start it off by multiplying to see what we get. So let's do, what do you want to do? Can we just combine these two here, the first one and the third one? Because a negative 6 plus a positive 6x would cancel, and then we would get negative 4y minus 4x z, and then equals, what is that? 8 and 18, negative 26. Okay, do you see that? Let's just check it real quick. I combined these, they canceled. I combined these, they're negative 4y. I combined these, they're negative 4z. And 8 and 18 made 26, and it was negative because they were all bad guys. Okay, grabbing my eraser because I've got like red squiggles all over the place here. What I did was the first and the third. So now I need to do another one. I can't do the first and third again. So I'm going to multiply this one by 2. Let me change colors. By 2, which is going to be 6x minus 4y minus 8z equals 16. And what I need to do is combine it with this top one here. So the 6x and the negative 6x get together and they just cancel. Over here I have negative 8y. No, it's 6. Negative 6y. Right here I have negative 6z. I'm seeing a pattern. Are you seeing a pattern? And then here I have a 16 with a negative 8, so I have 8. Okay, so now I have two equations that differ only, they have numbers and signs. Pretty much, you can see already that the answer is no solution, right? Can you? Can you see that? If you can't see that, you got to keep going, but we'll just keep going. We got to make a 12. So let's multiply this one by negative 3. Let's multiply this one by 2. So that's going to make us 12. We're going to cancel, and you'll see exactly what we're talking about. So we get a positive 12y. We get scribbles all over the computer. Okay, try it again. Positive 12y. We get a positive 12z. We're going to do 26 times the negative 3, so that is a 78. Here I get a negative 12y and a negative 12z and 16. When you add this, you get 0 equals a number. It's 94. Is that true? No, it is not. So it's no solution. Okay, let's see if the camera is working for that last one. Aha. Okay. So here I am, and I'm going to hit second and matrix, and I need to go over to edit, and I can press 1 for A, and it is a 3 enter, 3 enter, and it was negative 1, negative 5, negative 5, 4, negative 5, 4, 1, 5, negative 1. Now go second matrix, over to edit, and press 3 for C, and it is a 3 by 1. It was 2, 19, and negative 20. Okay, quit. Now we go and we get those matrices. So second matrix, 1 for A. This inverse button is the matrix button. And then second matrix, 3 for C. And we get our answer right there, negative 2, negative 3, 3. Okay, let's go back and see if we can find it. Negative 2, negative 3, 3 was right there. So I apologize that that was a little disorganized, but we got it taken care of. Okay, number 17. The members of the boosters organization at your high school bought new balls for the school. They spent $16 for a basketball and $24 for a football, and they spent $584. Okay, so they spent $16 for a basketball plus $24 for a football, and they totaled $584. Got it. Now it says, they bought 6 more footballs than basketballs. So who has more, footballs or basketballs? Footballs, right? They bought 6 more footballs than basketballs. So that means the footballs, or however many basketballs there were, plus 6 more. That's a 6. Okay, this is all set up for substitution. So if you want to plug this b plus 6 straight into that f, you sure can. But you know, I was really into calculators and matrices, so what I'm going to do is subtract the b to both sides. So I'm going to have 16b plus 24f equals 584, and negative b plus f equals 6. And so I'm going to go in my matrix with a 16 and a 24 and a negative 1 and a 1, and then a 584 and a 6. Let me see if I can show you. And it looks like the camera is frozen yet again. Sorry guys. I can't show you. But what you're going to do is go into your matrix and do that. We'll try it after we try 18. It says a stadium charges $70 for each seat in section A, $65 for B, and $40 for section C. Alright, so if you look at these, that's what you want to see. You want to see 70 with A. You want to see 70 with A. 70 with A. So 70 needs to be with A. So this one's wrong. 65 needs to be with B. So yeah. And 40 is with C. So they all have this one correct. There we go. It says there are 2 times as many seats in section B as in section A. There are 2 times as many seats in section B as in section A. Okay, who has more then, B or A? There are 2 times as many seats in section B as section A. That means B has more. B has twice A. B has twice A. B has, nope, not this one. B has twice A. Nope, not that one. B has twice A. Ta-da! And the answer is letter D down there. If you notice, which I didn't even talk to you about, but these were all the same. So we didn't even need to read that sentence or worry about that sentence because they were right there. All right, let's try that camera one more time and see if we can do our matrices. Nope, not going to let me. So since I can't show you on the matrix, what we'll just do is we'll get this out real quick here. Let me grab the eraser. And I'll even erase this bit here. Okay, so it's going to be 16b plus 24, and then f is b plus 6, equals 584. So 16b plus 24b plus 24 times 6 is 144 is 584. Do 584 minus 144, and then combine your 16 with your 24, and you get 40b equals 440. Do 440 divided by 40, and you get that B is 11. So B, basketballs, is 11, and that's the only one, so it's answer A. Hopefully you got it on the calculator. All right. Hey, that's it. We are done. Okay, I hope you learned something. Sorry about the technical difficulties. That's life, right? Have a great day, guys.